Oh, hello. Hi. Namaste. Welcome again. So, how are you guys? Welcome to Added, the place where we add knowledge to your brain on physics. Okay, now. So, myself, Tofik, and in this channel, I teach you physics for NEET and IIT and including CBS if you want to learn. Now, one more thing. Now, last class we discussed many topics. There are 5 conditions in that all we discussed deep as much as possible. No questions is left in that. Everything is clear. We will discuss questions in the end of this section. Last section was a little bit lengthy, so I cut it. Now in this section we will discuss all the questions. Don't worry, your syllabus will be complete. Okay, now let us get started with this beautiful day with a beautiful topic, cathode ray. Now cathode ray, very simple. When here it produces some, say, if it is negative, here it produces some kind of brightness. Now cathode brightness or cathode brightness or negative brightness, that is your cathode. Now we will study what is it cathode ray very deeply. Okay, now when the pressure of gas in the discharge tube is decreased, see this point is decreased, at some point Crookes discharge space fill the whole length of the tube. Very simple. When you decrease we already studied, when you decrease the pressure inside the discharge tube, the Crookes dot place completely all the full cylinder. Okay, the fact that the walls get glow. Very simple. When it is reduced, the walls of that cylinder or tube get glow, like your face. Finally, lagao, face chamkao, like that it will glow. And this process we call as fluorescence. Now shows that there is something coming out of cathode, traveling through the whole tube and falling on the walls. As we have discussed, there is something, stream of fast moving electron. This point is very important. Note down, stream of fast moving electron. This fact was recognized after a series of experiments carried out by Crookes, Thomson and others. They named this stream of cathode ray as, they named this invisible stream coming from the cathode as a cathode ray and established the following properties. Very simple. Don't break your head why I am here. I will explain everything. See, very simple, no? Okay, we'll write neatly. Neatness is very important. But in this pen and tab, we are not getting neatness. Okay. Now see, very simple. Okay, this was your negative, right? Negative. Now in the last section, in the last point, there was nothing you got. All Crookes dot place filled all over the point. But these 3 persons, just imagine, here one person is saying that this overall is there. Now here he is seeing some kind of brightness. Here this person seeing brightness. Let's say it as bright. Why? Now he is saying that there is its brightness, and he observed that there is something coming out from here, and he says that there is something coming out from here. He sees there is something coming out from here. Something. What is this something? There is something coming out of this cathode. What is it? He called this something as stream of fast moving electrons. Stream, it's not stream, it's a stream of fast moving electron. He called it a stream of fast moving electrons. Remember, this point is very important. This question I have asked in 2021 or 2001. It seems what is coming out of this stream of fast moving electrons. He said that stream of fast moving electrons, fast moving stream. After this, it will continue other, and they develop some extra masala. Now, after this stream, now he gives some properties, beautiful properties. Let us see the properties. Understood? First of all, concept understood. Clear? Concept is clear. Now, first property: cathode ray are emitted normally to the cathode surface. See, I just said now, if it is your cathode, the rays, which means electrons, stream of electrons, are coming out here like this. Now, if it is cathode ray, electrons are moving like this. Now it is perpendicular only now, perpendicular, 90 degree. In physics, for perpendicular we call as normal. Very simple, perfect. What we studied, we are discussing properties. That's all. Okay. But each and every property is very important. Now next property, the cathode ray travels straight line. Very simple, very simple. See here, all your brightness produced now, electrons produced now, it always travel in straight line. Whether this may be straight line here, or it may be straight line here, or it may be straight line here. But it's straight line. Okay, straight line and hit the walls. Okay, we know it. What, sir? Okay, sir, you are super, sir. Yeah, thank you, man. Thank you. I'm always super. Yeah. Cathode ray exerts mechanical force on the object station. Just now, last class we discussed when cathode ray, which means electrons, cathode ray. Okay, I will see. When cathode ray colliding with gas molecule, it makes this gas molecule to go from this level to higher level, which means this acting some force, that force we call as mechanical force. Mechanical means which making to do some work. Now it is striking and making to go from lower level to higher level. Last class we discussed. So cathode ray can act mechanical force. Now very simple. Cathode ray produces fluorescence when they strike number of crystals, mineral and fluid. See, very simple. Now if this is your glass made up of some material and made up of some material. Now whenever cathode ray or beam of electrons, stream electrons strike to the surface, it's produce lighting, which is known as fluorescence. Totally this point is telling whenever cathode ray strike with any crystal or salt as mineral, it will produce some light energy. Very simple, super. Now next point, when cathode ray strikes a solid object, especially a metal, X-ray is emitted. Very simple. See, I want to explain this. Now for suppose, imagine this is a metal, your metal. Now cathode rays, which means what? Stream of electrons. When it strikes on the surface of metal, it's emit X-ray. Rantavon, who invented X-ray? Rantavon. Okay now. It's emit X-ray. Very simple point, but important. Cathode ray can be deflected by electromagnetic field. See, very simple. It can be deflected. Remember, it can. Remember, it can be deflected, which means now it is moving. If here is some electric field, this can be deflect. This can fall here and deflect. And similarly, if this is your magnetic field, now electron, if it fall here, it may be deflect any direction. But there is a special case when you keep electric field and magnetic field at exact perpendicular. In this, if you accept electron, this time it won't deflect. This is a special case. This time won't deflect. Won't deflect. Clear cut, super. Now next point, cathode ray ionize the gas to which repulse. See, very simple. I said now, when here is a gas molecule, which has positive, negative. Now cathode ray falls up here and break it, which means ionizing it, breaking it to ions, ionizing it. Simple case, isn't it? Yes. Now cathode ray can penetrate to foils or material. foils, whatever metal foils, very thin foils is there now. It can penetrate to it. And E by M ratio of cathode ray is same for all gases. E by M ratio, I said in the last class, E by M means charge by mass ratio is same. Remember this point is also very important. It's same for all the gases. If you take whichever the other gases, E by M is same. Okay now. Okay. Now next property. Now properties are over. There are few properties. In this, every property is important. Now let us see. Electron, proton, neutron, tron. Have some chill with your physics. Now electrons were invented by your J.J. Thomson, and he got Nobel Prize in 1906 for this inventory. Now what all he invented, let us study one by one very briefly. Okay, J.J. Thomson. Now basically last lecturer. Okay, last lecturer. This is the last lecture, right? Yesterday, yeah. Okay, here we got to know that there is something coming out of, and it's striking, and it is brightness. This is clear. Now he stopped here. This scientist, what is his name? Crookes stopped. He did here, but this J.J. Thomson, he got some itching in mind. Oh, you are stopping. I will continue. You are stopping. I will continue. So he continued, and he discovered some electrons. He said stream of electrons is coming. He didn't particularly mention electron. He said stream of electrons. He continued and he said, see, let's read. J.J. Thomson confirmed that the Crookes hypothesis by applying electric and magnetic field perpendicular, special case, perpendicular across a discharge tube. Okay, man. Okay. Experimental demonstrated the speed and specific value of E by M of the cathode ray particles. Cathode ray is 0.1 to 0.2 times of the speed of light, and you know speed of light is 3 into 10 to the power of 8 meter per second. Oh, just a second. I put laptop charging, but forgot to on the switch. Okay, happens. It's okay. Now let me reduce some brightness. Okay, now this what is it? J. Thomson says cathode ray is 0.1 or 0.2 times the speed of light. Its time the speed of light is 0.1 or 0.2 times higher. Okay, now present value in this generation, the value of cathode ray is 1.76 into 11 coulomb by kg. Very simple. Now E by M is not dependent on the nature of material. See, it's not dependent on the nature of material, but the brightness is dependent. Okay, or the nature of gas. Remembering something, nature of gas. First point, when you get positive coulomb, which is depend on nature of gas, and fluorescence, which is depend on nature of glass. Nature of gas, positive coulomb. Nature of glass, fluorescence. Here, this is not E by M ratio is not depend on material or nature of gas used. It is independent and value is same for all. Value is same for all. E by M value is same for all gases. I said that E by M value is same for all the gases. Last we discussed the properties. Around 1887, it was found that the certain materials, when irradiated by ultraviolet lights, emit a negative charge particle. See, I will explain how it's going. First, let us study. Also, certain materials at high temperature produces a charge particle. Thus, E by M of these particles are found to be same as that of the cathode ray. Maybe different materials, but and different condition, but result is same. Okay. Ignore this one. Now see here. This is very simple. Basically, now before okay, I have one more page. Yes. Before we are calculating E by M ratio, this J. Thomson, this your father J. Thomson, by discharge tube, he got E by M value, but he has always doubted, is it E by M is true for all the things? Is it E by M value is true for all the things? He got to know that this E by M value is now independent of nature of material and nature of gas. But E by value is same for all or not. He has huge confusion. At that time, he saw that. See this point. At that time, say certain materials. See this one. Certain materials irradiated from ultraviolet light emit negative charge. Now, certain materials, let's say any materials, which strikes by UV rays, it's emitting some negative charge. You can say negative charge. And even when certain materials are heated materials, are heated, it is also emitting some negative charge. At that time, this J. Thomson measured the value of this E by M and measured the value of this E by M, and he got that both E by M values is same. This one, all values come to same value. Wow, shocking. In a discharge tube, I find E by M value, but that E by M value is similar to this negative value. So can I say that discharge tube value is because of negative? Yes. See, when I pass heat, the surface ejected some material. When I pass heat to some material, it ejected some negative charge. That E by M value is same to the surface which UV rays strike, emitting negative value. Okay. Now this value is same to the discharge E by M value. These both are negative. Then that also may be negative. That also may be negative. And that is your electron. And it is same for all the values. This is how we find E by M value. Now let us see this point once again. See this up to here point clear. Irradiated from negative charge particles, same speed, okay. Also certain materials at high temperature produce charges, okay. All those E by M are found to be same ratio, okay. Now, okay, this you got to know that it is E produce some value, E by M value is same. But what is the E by M value? E by value is same for the discharge tube, other surfaces, metal surfaces, other surfaces. But how to calculate it? What is the main value of E by M? For that, what he take now? In discharge tube, he take in discharge tube, very same man both. He found E by M value is same for all the metals and discharge tube. But what is that E by M value? That is we are discussing now. Now E by M value, to find this E by M value, first he took discharge tube. Okay, let us fill this discharge tube. Like this. Discharge tube, okay, no, I don't want this, I didn't like this, I don't like this. Now, we take some discharge tube, and for this discharge tube, see, this is anode, and this is cathode. We all know this basics. For this, he passes some electric field, and we know electric field passes from positive to negative. Electric field passes from positive to negative. Electric field passes from positive to negative. And it is passing like this. For this, he sent magnetic field like this. It is passing like this. For this magnetic field, like this, he sent magnetic field. So I can write it as into a will use some other. Into try to understand as much as you can. Positive here, negative here. Now electric field goes like this. For this, magnetic field is going like this, perpendicular both. Now in this condition, he exerted one electron. He exerted one electron. Now this electron have upwards electric field and downwards magnetic field. Right? See, I will write here. This is your electron. Now it has upward electric field and downward your magnetic field. Okay. Magnetic field. And he says that electron is going straight without deflect. See, we discussed that electron deflect by magnetic field, electron deflect by electric field. But we are passing both together. So it is not deflecting, it is going straight. Which means both the forces are balanced each other. So it is not deflecting. See, if it is only electric field, it will go like this, it will deflect. If it is only magnetic field, it will come like this, it will deflect. But it is going like this magnetic field, it is going like deflecting. But at the same time, electric field is acting, so it is coming outside, straight. Okay, which means you can say electric field is equals to magnetic field up. Yes, we can say. And you know, electric field is equals to Q by E, when magnetic field is equals to Q into VB sin theta. And this theta is equals to 90 degree because electron is this and your electron moving like this and your magnetic field is like this. Electron moving like this, magnetic field is like this. Now it is perpendicular. Electron moves like this, magnetic field like this, perpendicular. So it is 90 degree, perpendicular to magnetic. It is 90 degree. So what happens? It becomes Q by E into QVB, sin 90 is equal to 1. Now here charge is electron, here charge is your electron. So you can write like this. Now this one get cancelled. Now what remains? You will remind by V is equals to E by V. Velocity is equals to E by V. Remember this point. Now come here. One thing. Now we got this value. Okay, let us write. I will write very clear. I will write for you very clear because you are my beautiful NEET aspirants. Now we know that work done is equals to Q by V. Now don't ask how this comes. It is like potential, electric potential. We discuss electric potential in the second chapter. Electric potential is equal to work done to bring a unit positive charge from infinity to a point charge. Right, and in this chapter only we discussed that work done is kinetic energy storage. See, when charge is coming from infinity to a point electric field, this energy all is stored in the form of kinetic energy. So can I write this is equals to work done is equal to kinetic energy half mv square. Yes, this is your potential. This is your potential. This is your velocity. Difference irukka thambi, difference irukku. This is your 2. Difference irukku. Okay now charge here is E. Charge here is E 1 by 2 mv square. Now we are discussing the value of E by m. So I will write like this. Do you have any problem? Now velocity value we know. See, this is velocity, this is potential. How many times do I need to tell you? Potential. Now E by m value, can you write like this? E square divided by 2v d square. This is how he found E by m value. Simple thing, because you know why this Why you can say, sir, you can say, sir, you can easily shift, you can easily put the charge of E value which is 1.6 into 10 minus 19 and M value mass of charge I can find now. No, at that time charge is not found. Next person will find the charge. At that time charge is not found. So he found like this. Say E by value is just simple. Electric field he knows, magnetic field he knows, well potential he knows. This is your potential. This is your potential. Don't mistake. This is your potential. Potential. So he knows potential. He knows electric field is a magnetic field. He can find easily E by M value. Super, clear, mindset. Super. Very good. Now you got to know how you have demonstrated the E by M value, and this E by M value is same for all the gases. Okay. Now basically without this anything, let us tell you some E by M values of electron and photon. See, we will tell by okay. Next time we will see. Next thing we will see. Now come. Just now I said he was not knowing the charge value, E value, so he did that much hard work. But we know charge value. That charge value is found by this A.R. Rahman. RA millikan oil drop experiment. In this oil drop, very simple. We'll take a fluid in discharge tube. We'll fill discharge tube with the fluid. Just listen my words. In discharge tube, we'll fill that discharge tube with the fluid, which has density. Okay, see here. You are positive and you are negative. Now what happens? Very simple. Again. What is this? Magnetic field. Same what Thomson did same. And electric field is acting in this direction. Electric field, and this one is your magnetic field. Now, but only one thing is extra. We fill this. Okay, let me take one more. Okay, we fill this with some fluid. We fill this with some fluid. Fluid, and that fluid has a density rho. Okay, now in this we pass one electron. At that time this electron has some extra molecular activities through some extra forces. See, one force you know. One force, electric field. On downside, because it is filled with fluid, downside it is acted by Mg. It is filled with fluid, so downside Mg force acting. Upwards electric field. With electric field, there is one more force acting, which is upward thrust force. See, when you introduce electron and oil drop experiment, there are three things. One, upward electric field and upward thrust force acting, and downside Mg force is acting. Upward force. You can call it as upward force. It's not viscous. No viscous force. Only upwards force. Upward thrust force. Okay, now and electric field and downward Mg value. Okay, fine. We'll discuss the electric field. Before that, let us see some values. Okay, Thomson experiment described could determine the value of E by M. The value of electron in discharge E was established by millikan. I said now the value of E charge was given by this dirty fellow. Okay, to measure the charge of electron, he found that the charge on oil drop was always an interior multiple of electron. Okay. We'll discuss this question. First, let us see how he did this one. Okay, now. Okay. Basically, here how many forces are acting? Three forces are acting. One, your G. Sir, sing a song. Array, this is exactly night 9 o'clock, 9:30. Now what can I sing a song? Okay, now okay, I will sing a song. Before that, let me finish this. Now there are three forces acting. One, electric field with upward force is equals to your mg. Now can I send this mu is equals to this side? Yes, I can send this. And this we know, electric field is equal to q into E. And mg, here see, density is equals to mass by value, which means density is equals to mass by value. So which means mass is equals to density into value. So in the place of m, can I write this? Yes, of course I can write this. And similarly, it is fluid. Fluid also has some density. So fluid also has some density, which becomes like this. Fluid density, I said fluid density is like this. So can I write this with velocity? Let's see. Yes, of course I can write. Now I will keep charge here. We want charge, so I will keep charge here. And okay, fine. Can I write this final option? Yes, I can. And we are discussing about a oil drop, which is like this spherical. Oil drop, which is like this spherical. I will write here. Oil drop, which is like spherical. So what will the value? Value is equals to 5 by 3 pi r cubed. Now if I substitute in this, E is equals to 4 by 3 pi r cube into density of tell me, density of not fluid, density of oil drop minus density of fluid divided by into G divided by E. This is basically the final formula he found, and he substituted all the densities values, electric field values, and he got E value, which is exactly is equal to 1.6 into 10 to the power of minus 19. It is not exactly, but it is almost near to 1.6 10 to the power of minus 19, like that. Okay, adjust parwale, adjust. Okay, fine. Now let us know something extra. What is that extra? For electrons and for neutrons, for electrons and for protons. See, for electrons, E by m value, which is equals to like 1.6 into 10 to the power of minus 19 divided by 9.1 into 10 to the power of minus 31. Calculate. For proton, E by m is equals to 1.6 into 10 to the power of 19 divided by 1.672 into 10 to the power of minus 27. Now this will be higher and this is lower. Finish. This thing must be in your book at any cost. Simple thing. Now this is how he demonstrated the charge, value of charge. Okay. Now let us continue. Let us try to last few important topics. What is that? Emission of metal. See, I will tell you first, explain you all the stories. In metal, electrons are bound very hardly, very tightly inside the metal, and outside layer, it is valence bond. It is weakly bond. But If it tries to come outside, it can't come outside. See, it is, for example, it is metal surface. There is a final layer electrons. It tries to come outside, but it won't come outside due to attraction force. Little attraction force is there now. This is nucleus. It is final electrons. It will act some low quality of attractive force. It want to come outside, but it won't come because of this small attractive force. If it wants to come outside, we want to give some minimum energy so that it will come outside. That minimum energy is called as your work function. Now see, metal has free electrons, which helps them to conduction. Free electrons are help for conduction, right? Conduction. Okay. Free electrons normally can't see this one. Free electrons normally can't escape from the metal surface due to attractive force on inside materials of ion. I said now, see, I will tell you. This is your nucleus, first cell, second cell, just parvale. Now this cell has weakly bond. Now it's tried to come outside, but it won't come outside due to this low attractive. Now when you use some force, minimum force, so that it can break and come outside, that time it will come outside. That force is called as your work function. See, a minimum energy is required by the electron to escape from the surface is called as work function, and it is denoted by this symbol. And the measured value of work function, see, we know charge of electrons 1.6 megawatt minus 19. So we must give that much energy only now to come outside. It's not like charge of electron is 1, you are giving 100. What happens? Huge. We don't need. We just want 1. So charge E value to perform 1 electron outside, you have to give this much value. And we measure this work function in EV. It's not new vehicle EVs. It's EV. Okay. Work functions depend on the property of metal and nature of surface. See, it is the first time you are getting work function is depend on the property of metal and the nature of surface. Remember this. And work function has high for platinum 5.56, which means if you want to remove one atom for the 1 electron of platinum, you have to exert this much of energy. And for the lowest for cesium 2.14. Okay, nothing there. Basically, this electron emission is there. Now it can carry out by 3 methods. One method, thermal emission. Second, field emission. Third one, photon emission. Let's see if there is a one more page. Yes. See, thermal emission is very simple. Now we will see this one. Thermal emission. It's very simple. Now when we have a metal, when it is heated to certain temperature, at certain temperature, this metal emits your electrons. Very simple. Metal is made up of all atoms. When you heat, last valence bound electrons they escape outside. It is called as thermal emission. Very simple. When you give some heat to metal, it will emit some electrons. That's all. Okay. Now field emission. This is the disadvantage of doing class at 2 o'clock. Okay. Now field emission. Now what do you mean the field emission? See, field emission is very simple. I will show you. Field emission. Now, okay, I will take very neatly. Field emission. See carefully. Field emission. This is your positive and negative anode and cathode. In this, if I keep a metal inside this and pass very high electric field, high electric field going from here to here, entering and coming outside. At this time, what happens now? This metal has some electrons which moves like this, and which comes outside. which comes outside, which comes outside. This is called your field emission. When you give a high energy, high electric field to the metal inside this anode and cathode, these electrons in this metal move outside. It's emit outside. It is called as your field emission. Now one more last thing, field emission over. One more last thing, photoelectric effect. Photoelectric effect. Photoelectric effect. It's very simple. Very simple. Now, if I have any surface, metal because metal only have electrons, metal only can conduct electricity. So if we have this kind of metal, now we have your Surya Devata, sun. This sun acts some radiations on the metal. Due to this radiation, this metal emits electrons. This is called as your photoelectric effect. Okay, now fine. Now that's it. All we discussed many topics. We discussed about our crookes and J. Thomson. And after J. Thomson, we discussed about electron. Who is that millikan. And after we discussed all the properties, electron E by M value, and we discussed collision, electron collision, and emission and types and all. Okay, now let us see some questions. See, first question. In a discharge tube, ionization of enclosed gas is produced due to collision between. See, very simple. In the discharge tube, the ionization of gas produced due to collision between. Ionization. See, ionization. Understand. See, I said you now. Ionization. It is a gas molecule. It has positive, negative. Now electrons will hit here. Positive, negative means it is neutral. Hit here and make it to go from ground level to higher level. Okay, now let us see which option is correct. Now neutral gas atom and molecules. Neutral gas atoms and molecules. Positive ions and neutral atoms. See, understand each and every answer. Neutral gas molecules and atoms. He's telling it is because the collision between these neutral molecules and gas molecules. No chance. Now one more thing, positive ions and neutral atom. Is it because of positive ions? No. This also no. Third one, negative electrons and neutral atom are molecules. See, I said in negative electrons, neutral molecule. Correct answer. Simple. Now one more. Protons and neutrons are atoms, molecules. No answer. Try to understand question. Okay. Now next one. In the phenomena of electric discharge to gases at low pressure, the colored glow in the tube appears as a result of. See, 2008 it has asked in NEET. So this is a very simple phenomena. In the phenomena of electric discharge to a gas, okay, at low pressure, which is low pressure, the color glow in the tube appear as a result of. Very simple. This is a discharge tube. Now they are telling in the discharge tube, the color glow appear as a result of. Okay, color glow. Let us see. Collision between the charged particle emitted from the cathode and the atom of gas. Yeah. Okay. Collision between different electrons of atom of gas? No. Excitation of electrons? No. Collision between atom of gas. Which one is right? First one only. See, I will tell you why. Electrons are moving here. It is colliding with gas molecules. Colliding. These gas molecules moving upward, and it is unstable here. It is coming outside. While coming, it emitting some radiation. If radiation is emitting, then it is bright only. Now it is glow only. So which one is correct? Which one? Collision between the charged particle, electron, emitted by cathode emitting, which means electron, and the gas molecules. Simple case. Super. Now, which of the following is not a property of cathode ray? 2002 it has asked which are the property. I said 10, 12 properties. That properties. See, okay. It produces heat effect. It is true. See, I said now electrons hit on gas with a mechanical force. Mechanical force, I said you now. If it is producing some mechanical force, if it is hitting mechanical force, then it produces some heat. Hey, Tambe. No, wait 1 second, guys. I'm just trying some new things, it's not going on. Okay, now second option. It does not deflect electric field. Did it glow here? I said electrons deflect by electric field. It deflect, go like this, and it is deflect by your magnetic field. Magnetic field. He is telling it is not deflected by electrons. And we have to find which is not. This is the right option. This is correct option. And it caused shadows. See, this is one point. Now, if it is perpendicularly coming from this point, perpendicularly coming. Now see, it is perpendicularly coming. If it is coming like this, now do it have some shadow here? It is coming outside. It's shadow here. So it has shadow. Write down this property. Write down this property in your thing. This is true. And it produces fluorescence. This property, this one is true. And this one is false, which means this is your right answer. Where is my marker? Okay. Now next question. J.J. Thomson cathode ray tube experimentally demonstrated that. Okay. J.J. Thomson tube, which means E/M ratio. J.J. Thomson tube experimentally demonstrated that cathode ray are stream of negative charge ion. All the mass of atoms is essentially in this we will study in next chapter. Atoms. It's a different story. The so E/M of electron is much greater than the proton. Is it right? No. I said now, proton is higher, electron is lower. So wrong answer. This is not there. Wrong answer. Now E/M ratio of cathode ray particles changed when a different gas. I said E/M ratio is same for all the gases. So this is also no option. Remaining is this one. I said, you know, this emits stream of electron. See, this one fellow absorb and said now stream of electrons. Okay. Now next one, Thomson mass spectrography. E perpendicular to B, then the velocity of electron beam will be. See that one. We discussed velocity of E/V. What is that? If electric field and magnetic field is perpendicular to each other, then the velocity of electron beam will be. Which one is the right answer? Fill it. Which one is the right answer? Velocity. Both are perpendicular. So this becomes your right answer. Okay na. Now next question. A beam of cathode ray is subjected to cross electric and magnetic field. The electric field are adjusted such that beam is not deflected. The specific charge of cathode ray is given by. See what they are telling. Now boys and girls, we are keeping anode and charge, one side cathode, and we are following some electric field, and to that we are passing some perpendicularly magnetic field. In this we are putting some electron. At that time, that specific charge value is what? Specific charge value means E/M value is what? And we discovered that what we discovered E/M value, it is acted by electric field is equals to magnetic field. Electric field is equals to Q by E. This is equals to Q into B into V sin theta. Right? What we got answer? We got answer. What we got answer? Okay, let's see. This one get cancelled, and this becomes 1, which means velocity is equals to E by B, which means our right answer is this. We got now. Wait, I will show. Oh. See here. E is equals to E by M is equal to E square by 2V square. Future kids, future doctors, future engineers, future IITians, what are you doing? Okay, how many slides are remaining? Okay, 3 slides. Okay. Now the who evaluate the mass of electron indirectly with the help of charge. Mass of electron, it means last one. E value we put, M value we put. Who evaluated this? Who find this? Who? Tell me who? We know. He is the greatest fellow, millikan. Easy thing. Easy. And thermions. See, I said thermal emission. When we have some metal, when we heated it, these electrons emit from this side. This is due to thermal emission. This is due to thermal emission, and this is called as thermal ions. Thermal ions are thermions. This thermions is basically negative, which means here negative, which means electron. Simple case. Now last question. In which of the following emission the electron does not take place? Remember, electrons are not coming outside. Electron does not take place. It means electrons are not coming outside. Something else is coming outside. Thermal emission, thermions is coming. Photon emission, which means negative is coming. Secondary emission, it is also electrons are coming. Remaining X-ray. In X-ray, X-rays are coming, not electrons, which means 1990 X-rays is coming. Fine. All these answers we got. Now let us see. Points to the type of equations here. Okay, types of equation. Here, points to be noted. Now remove this type of equation. Strike it out. Points to be noted. There are some points which you have to note. See, photon of light. Remember, photon of light particle with wavelengths have same energy and same momentum. See, if you take any light, maybe white light, red light. White light has all the wavelengths. Okay, white light has all the wavelengths with pair. Okay, in that, if red light having some wavelength, its wavelength is same for all red lights. It's nothing deflecting. It is same for all the wavelengths. It is same for all the red wavelengths. If one red light has something wavelength, it is same for all the lights. All the red lights, and same energy. It is calculated by hc by v, Planck's constant, speed of light divided by velocity, and same momentum. Okay. The collision of photon with a material particle is assumed to be perfectly elastic collision. See, photon colliding with a particle, it's perfectly elastic collision. This you remember. Okay. Now, if the intensity of light is given, wavelength is increased. See, very simple. If the intensity of light of a given wavelength is increased, intensity, you are increasing intensity. If you increase intensity, the number of photons increases. With number of photons will increase, but energy of photons remains same. Energy, this. If you increase intensity, number of photons increase, but energy of each photon, is same, remain same. Clear? Okay. Now I think you got all these values. Okay. Now here we cut this class because class is over. I hope the introduction of this chapter is clear for you, and all this emission and all this previous question is clear for you. If it is, we will meet in next class. We will discuss more romantic and more beautiful concepts here, and meet you in the next class. Until that, take care, tata, bye bye, have a great day, and complete this one. If you want these notes, you need to join the WhatsApp group or WhatsApp community, WhatsApp channel, which we have given in the link description. Join there, have test series, have some fun there. Okay. Now we'll meet in the next class. Until that, tata, bye bye, see you.